What is the ideal self-managed monitoring and logging stack, especially if you're using Kubernetes? Now, before I answer that question, let me stress one more time that I'm talking about self-managed tools. If you prefer using SaaS, that's great. You should actually continue doing that. But this video is about self-managed, not software as a service. So let's get going. Let's see what is the ideal monitoring and logging stack. There are quite a few things we need to put to assemble monitoring and alerting and logging and so on and so forth, and we're going to start with metrics. The golden standard for metrics today is nonetheless than Prometheus, project in the CNCF Foundation, and it's been kind of a standard. Kubernetes is exposing its metrics in Prometheus format. Most of the applications that you might be running in Kubernetes are also doing the same, are exposing Prometheus endpoints. So it is a standard, and for a good reason. So let me take my cluster. I already have a cluster. I did that in advance, and install Prometheus. The command is relatively straightforward, at least if you're using Helm. So Helm upgrade, we want to install, if it doesn't exist already, a name, the chart, namespace. I want to create a namespace, the values. There's not much happening over there, so no need to show you the values. And I'm going to set the host to be Prometheus.whatever is the IP of my cluster, or external load balancer to be more precise. And I love using nip.io for the demos, not for the real thing. So let me get the address and open it in a browser and take a quick look at how Prometheus looks like. Now, beware, I'm not going to go into details into everything you should know about Prometheus or any other tool that I'm going to feature today. This is just a quick overview of what you might want to combine and explore yourself. Now, one cool thing about Prometheus, amazing thing, can be observed if you go to the targets section, and over there we can see that Prometheus is already monitoring. Actually, let me stop for a second and say Prometheus is a pool-based mechanism. So Prometheus is pooling metrics from different destinations, from different locations, unlike other mechanisms that are pool-based, meaning that we have an agent that is pushing metrics to some central database. This is the other way around. So Prometheus, once installed, by default, is already figuring out what to watch for. And we can see that it already figured out that there is API server of Kubernetes itself, that it should get metrics from there, that it should get metrics from the nodes, CAdvisor, which I'm not sure how useful, actually it is very useful. It gives you the metrics of containers themselves. It watches for pods, it watches for endpoints, it monitors itself, and finally, out of the box, it watches for the push gateway. I will explain push gateway in a couple of minutes. For now, just remember push gateway is there. It could be extremely important, especially for legacy stuff that might have trouble getting into the cloud native game. So Prometheus does three things essentially. It pulls metrics from whichever locations it discovers. It stores those metrics in its internal database, time series database, and it allows us to query those metrics and find out whatever we need to find out about the system. And that language for querying is called PromQL. So let's take a look at one or two examples of how that looks like. So let's say that I want to find out what is the CPU utilization of the containers running in my cluster. Well, the simplest possible query would be just to list all the results of a specific metric, which is container CPU usage seconds total, one of the many metrics, and then hit that execute button. Now, assuming that you don't like reading a lot of text, we can switch to graph view, and over there we can see how is CPU doing, how it is going. Now, one thing you should notice or know from the start, that some metrics are cumulative. So we do not see what is the current usage, we see what is the cumulative usage of CPU over a period of time, essentially from the very beginning. Now, if we would like to see what is the CPU usage, the real CPU usage, not cumulative, but what was it at any given point in time, we can extend the query and say, hey, give me the rate of that metric accumulated over fractions of 5 minutes. And then once you figure that out, you will probably figure out that there are many functions that PromQL supports, and then you would need to go to the documentation and figure it out, read it. It's like good literature, right? Now let me go back to the query. Let's say that I would like to find out what is the CPU usage in a given namespace, in a specific namespace. Then I would extend my query to limit actually the results to a specific namespace. Or I could limit it even further, and by the way, limitations are going through labels. Each metric has a number of labels associated with it, and we can use those labels to filter the results. And I can say, hey, it's not only about containers in that specific namespace, but I would like to see CPU usage of containers with a specific name, and then I would get a more limited or more focused result. So apart from Prometheus, which is already running in a cluster and it is fetching metrics from Kubernetes API, we also got node exporters. There is one node exporter on every single node of the cluster, and Prometheus is getting metrics from there as well. Further on, we got push gateway. Now, push gateway is interesting. Since Prometheus can only pull metrics from somewhere, that poses a problem because some metrics, some applications, some parts of the system might not expose metrics in a way that Prometheus can get it from there. So we have push gateway. Push gateway is yet another destination that Prometheus is watching and pulling metrics for. So whenever we have something that cannot expose metrics in Prometheus format, we can actually use push gateway to push metrics over there, and then Prometheus pulls it from there. And that can be anything, any application, anything that you want can theoretically and in practice be reconfigured or changed slightly to push metrics to the gateway, and from there on Prometheus will get it. What else did we get? Oh yeah, alert manager. So I think that's the final important component in what we got with Prometheus, not everything that we are going to explore. There are other things. Anyways, alert manager is querying Prometheus constantly or periodically for certain rules, and when those rules are reaching, no, not rules actually, when those queries based on those rules reach certain thresholds, alert manager will send notifications somewhere, and that somewhere can be Slack, it can be email, or anything else. So alert manager is in a way querying Prometheus periodically and saying, hey, is this okay? If it's okay, then there's nothing for me to do. If it's not okay, I'm going to send notifications somewhere. Now that part might be the part that I like the least. Alert manager is a bit not really friendly, let's say, and I believe that there are better solutions, namely Robusta. Now, if you haven't seen Robusta then, or if you haven't used Robusta, you should. And if you're not familiar with it, well, I made a video. There is the video in the description somewhere. Go and check it out. Now that we have everything we need to collect and query metrics and get alerts, more or less, stop this video. This is the future me talking. This video is sponsored by Robusta. Hey! So, Robusta is a platform for Kubernetes notifications, for troubleshooting, and for automation. Within the context of this video, it complements Prometheus and Alert Manager. It has a very easy setup, a few questions through a CLI wizard, and off you go. You get notifications to Slack or MS Teams if that's what you want, whenever something goes wrong or whenever you want to be notified about something. Now, truth be told, Alert Manager does something similar, but Robusta puts it on a very different level. It is much better and much easier to work with. It comes with out-of-the-box playbooks for commonly used alerts, and if that's not enough, you can create your own playbooks. And that is going to be easier than creating your own alert manager queries. On top of that, the alerts come with the context. Imagine context. Instead of something somewhere failed, go figure it out, you get the information you need to almost immediately understand what's going on. So, long story short, please try out Robusta. It's a great tool and I strongly recommend it. And at the same time, by trying Robusta, you'll be helping this channel a lot. Now let's get back to the original video. Let's talk about logs. How do we collect logs and what do we use to collect them? Now, in the past, long time ago, if you're young, you might not know those times, but long time ago, we were putting logs somewhere, right? We have an application, and there would be a directory next to that application where we write logs, and then logs would be all over the place. The bigger the system, the more locations, the more places we had with logs, and you can only imagine going through logs spread across many different servers was painful, extremely painful. In the meantime, most of us understood that logs should be managed centrally, and they are distributed by nature, meaning that logs are being created everywhere, and then we need to collect those logs, get them from everywhere, and push them somewhere. Now, there are many solutions for that. The most famous, most commonly used, at least in the past, would be Elasticsearch, Logstash, and Kibana. Logstash, namely, which would be collecting logs and pushing to Elastic. But today I'm not using Elastic because this is better. There is something much better, and that something much better, at least in my opinion, is called Loki. So let me install Loki with a simple command, helm upgrade install. The name is Loki, Grafana, Loki stack is where it's located. The namespace, yes, the namespace is monitoring. I want to create a namespace and I want to wait. And while I'm waiting for Loki to be installed, this might be a good opportunity to remind you of something extremely important. And that important thing is subscribe. Right now, go, subscribe. And then like the video because it's awesome, right? Now let's get going. Let's see what we get with Loki. Actually, there is not much to see. There is nothing to see with Loki because we are missing a crucial component. We are missing a way to visualize logs and other stuff. So for now, let me explain what it's doing, and later on we are going to see it in action. So what it's doing, well, it's sitting in a cluster and waiting for something to push logs into it. So it's a database specialized for logs, and that's something, that entity pushing something to Loki in this case is called Prometheus. So just as we have exporters which are providing metrics on each node, for Prometheus, we have Prometheus running on each node of the cluster, watching for all the logs happening in containers in that node, in that server, and pushing those logs, streaming them to Loki. So this is opposite from Prometheus. Prometheus is pooling metrics, but in case of Loki, metrics are pushed from nodes to Loki itself. And there is a good reason for that. Prometheus is not collecting every single metric. It is aggregating metrics because it would be just overwhelming, but logs are different. We need every single log entry. So we have Loki, actually Prometheus, pushing logs to Loki, which is a database for logs similar to, let's say, Elastic, except that Loki is specialized for logs and logs only, and it does it really well. And now comes the moment that everybody's waiting for. How do we watch those things? Prometheus is great for querying, but not really for observing what's going on. And there is no interface so far that we can use to observe the logs in Loki. So we need a visualization tool. We need a sort of dashboard. There are very few dashboards or very few applications, third-party applications, that became so indispensable as Grafana. Grafana is a ruler of its own domain. Almost nobody is disputing that it is the de facto standard to aggregate, fetch, and visualize metrics, logs, or almost anything else. We are going to connect it and get metrics from Prometheus and from Loki, but in theory and in practice, you can use Grafana to get stuff from almost anywhere. That's what makes it absolutely awesome. Now, installation of Grafana could be just as simple as installation of the previous tools I installed and applied to the cluster, but I'm going to complicate it a bit more because I want not only to run Grafana, the engine itself, the UI itself, but I want it already to have some dashboards baked in, and I wanted to have some data sources baked in, meaning that I wanted to know from the very beginning where to go to get information and so on and so forth. So my Helm chart values file is this time more complicated. There are usual suspects like, yes, English should be enabled, but then there are some less usual sections. To begin with, there is data sources where I'm saying, hey, you should be fetching metrics from Prometheus, and you should be fetching logs from Loki. Those are the addresses. Go get information from those two databases of sorts. Don't ask me much more about it. We have a database provider, which is a silly thing that I'm not going to even bother explaining because it's extremely silly. And then we have dashboards. Now, in this case, I'm having only one dashboard, a single dashboard, and you should probably figure out that you can have as many dashboards as you want. I'm going to use a dashboard that already exists, that was made by somebody else, somebody who contributed to the community. And what matters here are two things. First of all, the ID of the dashboard is 10,000. I'm going to get back to that ID, and the data source is Prometheus, meaning that, hey, that's the data source. That's where you get information to visualize it using this dashboard. Now you might be asking, hey, how do you know? What the heck is dashboard 10,000? Well, let me show you how I found out that I want exactly that dashboard. If you go to grafana.com/grafana/dashboards, you will see all the dashboards that were contributed to the projects by different individuals and companies and so on and so forth. And then you need to know what you want to visualize. In my case, Kubernetes, but it can be anything else. This is very high level. You could go drill down into Kubernetes, or you could visualize almost anything else. And once you find out what you want to do, you search for it and you find the one you like, or you find multiple and then check them out. And in my case, I found a dashboard for Kubernetes, which happens to have the ID 10,000. So let's go back to the terminal and let me install Grafana by a typical command, Helm upgrade install Grafana. Namespace is this one. I want to create a namespace. I want some values. I'm going to set the host to be whatever it is, and I'm going to wait. This time I'm not going to tell you to subscribe to the channel because you already did that, and I don't have to wait long. So there we go. I have my Grafana up and running. Now, if you paid attention to the instructions, you will see that we should retrieve the secret so that we can do the initial authentication to Grafana. So I'm going to copy and paste that command and execute it. And then I will get as the output the password that I should be using to log into Grafana. And with that in mind, let me open it in a browser and see what we'll get. Username is admin, password is whatever is in the output, and let's see it in action. First of all, let's go to the dashboards, and over there is only one dashboard. That's the famous 10,000 Kubernetes dashboard. And if I go inside the dashboard, we can see that there are some colors moving around and some numbers and stuff like that. I will let you explore that dashboard yourself. You can change the namespace, you can change the duration of the metrics or how long you want to observe something, and so on and so forth. Do it yourself. Pretty colors. That's important, right? Better than Netflix. So going back to the diagram, we got Grafana in the cluster, and then a human, a person, can go to Grafana and visualize things, in this case through dashboards, but there are other ways to visualize as well. And in this case, so far, Grafana is fetching information from Prometheus. But that's not the only place it is getting information from. It is getting information from Loki as well, this direction, I think. So let's take a look at whether we can find out something about the logs. Can we query the logs stored in metrics, but query them through Grafana? Now, apart from dashboards, and trust me, you can have dashboards for logs as well, if that makes any sense. I don't think it does, because logs serve a different purpose than monitoring. But if you want, you can have dashboards, but I'm not going to use dashboards. I'm going to go to the Explore section, and over there I can query any data source or data from any data source currently connected to Grafana. So I'm going to select Loki, or it's already selected, and then I'm going to type a query that is very similar to PromQL, just tweaked to be appropriate or tuned for logs. Actually, let's postpone Loki. Let's go to Prometheus first and see whether we can query Prometheus. Can we execute the same query from Grafana that I executed in Prometheus, apart from seeing the metrics in dashboards. So let me copy and paste the query from before and put it into Grafana. Make sure that you select Prometheus as data source, and ta-da! There we are. Those are the same metrics, different dashboard, different visualization, but the same metrics. And that's very important because in this way we can visualize things. We can have a single place where we visualize information or data from multiple sources. So for Loki, we can write a query ourselves, or we can select what we want from a drop-down, not drop-down, below the query field, the search field. We can select an application, and that would give us a starting point, and from there on we can query whatever we want to query. We can extend those selections by custom querying, writing. I'm not sure what's the language. It's not PromQL, it's something, LokiQL, or I'm not sure what the name is, but it's very similar to Prometheus query language. Anyways, the logs are there. Not much is happening in my tiny cluster, but that's enough to see that logs are being collected, being shipped to Loki, and I'm using Grafana to visualize them, to search for them. Not much visualize, but more query. So that's about it. That's the perfect combination for at least in my opinion, perfect combination for self-hosted, not managed, not SaaS, but self-hosted monitoring, logging, alerting, and is there anything else? No, that's it. Monitoring, logging, alerting, system, mechanism, platform, whatever you want to call it. Try it out if you haven't already, and if you feel that there are better solutions, please let me know in the comments. I would like to hear what are the better self-hosted solutions. SaaS is a different beast because we do not need to care about some things and we might care about others, but let me know in the comments. What do you like? What is your preference for monitoring, logging, and alerting? Thank you so much for watching. See you next time. Cheers.